Here we have a problem on definite integral. That is, we have to evaluate the given definite integral and round our answer to 3 decimal places. Okay, first what I'm going to do is I'm going to evaluate the given integration as an indefinite integral. Once I get the result of the indefinite integral, then I'll apply the given limits. That is, a lower limit natural logarithm of 6 and the upper limit natural logarithm of 27. Okay, now let me evaluate this one as an indefinite integral. That is without the given limits. Okay, let me write it. So integral 3 times e to the power of negative x over square root of 1 negative 9 times e to the power of negative 2x times dx. Okay, I have written the given integral as it is without the limits. That is, I have written it as an indefinite integral. Okay, now what I'm going to do is I'm going to write this 3 times e to the power of negative x along with this dx. Then we'll have 1 in numerator. Let me write it. So integral 1 over square root of 1 negative. And also this 9 can be written as 3 square, and this e to the power of negative 2x can be written as e to the power of negative x whole square. And we can write this one with dx over here. Then we get 3 times e to the power of negative x times dx. Then we get integral 1 over square root of 1 negative. Here, two terms are multiplied with the same exponent 2. Whenever two terms are multiplied or in division with the same exponent, what we can do is we can take the exponent in common. That is 3 times e to the power of negative x whole square times 3 times e to the power of negative x times dx. And also we can consider square for this one. So why should I consider square for this one? Even if I take square for this one, it's still equal to 1. Okay, there is a reason. Let me consider the formula in integration, that is integral 1 over square root of a square negative x square times dx. Whenever we have a function in this form, 1 over square root of a square negative x square, and if I want to integrate this function, the result of this one is arc sine x over a positive c. Okay, so in order to get this integration in this form, I wrote this 9 as 3 square and this e to the power of negative x as e to the power of negative x whole square. Finally, I wrote this one as 3 times e to the power of negative x whole square. And also I need a square. So here we have 1, but the 1 over here should be written in the form of a square. That's why I've taken square for this one, but still it is equal to 1. Okay, anyways, I got the stuff over here in this form, but still there is a thing here. There is a variable x and the x is square. There is a single variable squared over here, but instead of single variable we have a constant 3 and it is multiplied by e to the power of negative x and it's squared. So at the place of 3 times e to the power of negative x, I need a single variable like x, what we have over here. So what do we have to do for that? For that we have to use substitution. So that is let u equals to 3 times e to the power of negative x. When I substitute a new variable u for this one, I'm getting u square over here. That is a single variable squared. Okay, since I have substituted a new variable u, now what I have to do is I have to get this complete integration in terms of the new variable u. When I get the complete integration in terms of the new variable u, at the place of dx, I must have du, so that I'll be able to integrate with respect to u. If I want to get du at the place of dx, what should I do with this u? I have to find derivative. If I find derivative of this u, I'll be getting du. And also here, u has been defined as a function of x. Since u has been defined as a function of x, now we can find derivative on both sides of this equation with respect to x. When I find derivative of this u with respect to x, I am getting du over dx. Here, when I find derivative of this stuff, so 3 is a constant multiplied by the variable part. So we have to keep this constant 3 as it is. When I find derivative of this e to the power of negative x, still I'm getting e to the power of negative x. By chain rule, when I do further derivative of this negative x, I'm getting negative 1. Then I'm getting du over dx equals to, when I multiply this 3 and negative 1, I'm getting negative 3 times e to the power of negative x. Okay, now let me multiply both sides by dx so that I'll be able to get rid of the dx in denominator. Okay, so now dx will cancel. I'm getting du equals to negative 3 times e to the power of negative x times dx. Okay, here when I consider the integration, here we have 3 times e to the power of negative x dx. We have the same stuff over here, but there is a negative sign. Okay, now to get rid of the negative sign over here, we have to multiply both sides of this equation by negative 1. When I multiply this du by negative 1, I'm just getting negative du, and when I multiply this stuff by negative 1, I'm getting 3 times e to the power of negative x times dx. When I multiply this stuff by negative 1, the negative will become positive, and 1 times this stuff is the same. Okay, now what we can do is in our next step, we can plug in u for this 3 times e to the power of negative x. That's what we have done over here. And also for this 3 times e to the power of negative x dx, we can plug in negative du. Okay, now let me continue on the next page. So we have integral 1 over square root of 1 square negative u square times negative du. So here what I've done is for this 3 times e to the power of negative x, I just plugged in u, and for this one I plugged in negative du. Okay, so why do we do all this stuff? That is the u substitution and the stuff what we have done to make the integration process easier. We are doing all this stuff. So look at the look at this integration over here. It's a little complicated. Just look at the integration after u substitution. So it becomes simple. So easily we can integrate. So to make the integration process easier, we do u substitution, and also we can move this negative sign out of the integral. Then we get negative integral 1 over square root of 1 square negative u square times du. Already we have discussed the formula over here. That is integral 1 over square root of a square into x square times dx equals to arc sine of x over a positive c. Okay, now this integration is exactly in this form. At the place of a square we have 1 square, at the place of x square we have u square. Then what is the integration for this one? That is arc sine x over a. X over a means u over 1, because at the place of x we have u and at the place of a we have 1 positive c. So here I'm adding constant of integration because it's an indefinite integral. Whenever we evaluate indefinite integral, so in the result always we have to add the constant of integration c, and now we get negative arc sine. So u over 1 is just u positive c. Actually u is a variable taken by us. It has to be replaced by the original stuff. What is the original stuff? We know that u equals to 3 times e to the power of negative x. We can plug in this 3 times e to the power of negative x for u over here. 3 times e to the power of negative x positive c. Okay, now I got the result of the indefinite integral over here. That is integral 3 times e to the power of negative x divided by square root of 1 negative 9 times e to the power of negative 2x dx. Okay, so we have to evaluate the same integration but with the limits, given limits ln 6 as lower limit and ln 27 as upper limit. Okay, now let me evaluate the same integration with the limits over here. Let me do it. So integral ln 6, and here we have ln 27 3 times e to the power of negative x divided by square root of 1 negative 9 times e to the power of negative 2x dx. Okay, now so in the result on the right side we can skip the constant of integration, because usually we do this for indefinite integral, but now we have a definite integral, so we don't need this constant of integration. Now for this result we have to apply this limit, the lower limit ln 6, upper limit ln 27. Okay, and also the limits we have over here will do nothing with this negative sign, so we can apply the limits only for this stuff over here. Then we get negative of arc sine 3 times e to the power of negative x. The lower limit is ln 6 and the upper limit is ln 27. Okay, now what we have to do is here these are the limits of x. So in this result, at the place of x, first we have to plug in the upper limit ln 27. Then I'm getting arc sine 3 times e to the power of negative ln 27. Now I have to take a negative sign. Now again in the same result we have to plug in the lower limit. So before we take the lower limit we have to take negative sign, and this result, in this result for x we have to plug in the lower limit ln 6. Then I'm getting arc sine 3 times e to the power of negative ln 6. Okay, so now what we can do is we can distribute this negative sign to this and this. So what we can do is, what we get is a negative arc sine 3 times e to the power of negative ln 27, and negative times negative will become positive arc sine 3 times e to the power of negative ln 6. Now let me consider the power rule of logarithm. That is, for example, log base a m to the nth power equals to, here when I consider the argument of the logarithm, it's a power. Here we have base m and exponent n. So whenever the argument of a logarithm is a power, now what we can do is we can move this exponent of the argument in front of the logarithm, and it has to be multiplied by the logarithm. That is n times log m to the base a. Okay, now we can think about the power of logarithm in reverse order. That is there is a value multiplied in front of logarithm. Now what we can do is we can take this value as the exponent of the argument over here. Now let's consider the same stuff over here in this logarithm. So what value do we have in front of this natural logarithm? So there is just negative sign. We can assume it's a -1. Since there is a value -1 multiplied in front of logarithm, it can be moved as an exponent for the argument of the logarithm 27. The same thing we can do over here. We can assume there is a -1 in front of logarithm. This -1 can be taken as a exponent for the argument of the logarithm 6. Okay, now let me do that in my next step. Let me continue over here. Just a moment. Okay, negative arc sine 3 times e to the power of, now as if there is a -1 over here, I'm going to take this -1 as an exponent for the argument of the logarithm using the power rule of logarithm. Then I'm getting ln 27 to the negative first power positive arc sine, let me write it, 3 times e to the power of ln 6 to the negative first power. Okay, now when my next step, what I can do is I can write this 27 to the negative first power as 1 over 27. Okay, now let me continue on the next page. So we have one negative arc sine 3 times e to the power of ln of 1 over 27 tan positive arc sine, let me write it over here, 3 times e to the power of ln 1 over 6. Okay, now we can verify. So now what I've done is like I just wrote this 27 to the negative first power as 1 over 27, 6 to the negative first power as 1 over 6. Okay, now let me consider a property in logarithm, that is let me consider base a, and this base a is raised to the power of log y to the base a. Here we have an exponential term, that is here the base is a and the exponent is logarithm, and the logarithm of the exponent is also in the same base a, that is whatever base we have over here, the same base we have for the logarithm of the exponent. Okay, whenever we have an exponential term like this, that is the base over here, the base of the logarithm and the exponent are same, so the result of this one is the argument of the logarithm, that is y. Okay, now using this property, we can evaluate the value of this ln of 1 over, e to the power of ln of 1 over 27. Let me write it, e to the power of ln of 1 over 27. Okay, here the base is z. Here this is a logarithm. So since we have the spelling ln, we can understand it's a natural logarithm. Natural logarithm will always have the base e. Okay, here the base is e, and the base of the logarithm of the exponent is also the same e. Then what is the result of this stuff? That is the argument of the logarithm, which is 1 over 27. So the same thing we can do with we can do for this one, that is e times ln to the ln of e to the power of ln of 1 over 6. So the result of this one, so this is also natural logarithm, so the base is e. So here and here we have the same base, so the result of this stuff is the argument of the logarithm, that is 1 over 6. Okay, now let me continue over here. So negative arc sine 3 times the result of this stuff is just 1 over 27 positive arc sine 3 times the result of this one is just 1 over 6. So 3 goes into 3 1 times, 3 goes into 27 9 times, and 3 goes into 3 1 times, 3 goes into 6 2 times. Then we get negative arc sine 1 over 9 positive arc sine of 1 over 2. So now I can write the positive term at first, and I'm getting arc sine 1 over arc sine of 1 over 2 negative arc sine of 1 over 9. Now we can evaluate the value of this expression using a calculator. So here we have inverse trigonometric functions, that is arc sine over here, arc sine over here. Okay, when I evaluate the expression which contains inverse trigonometric functions, we have to make sure that our calculator has to be in radians mode. Usually our calculator will be in degrees mode in default. So if you keep your calculator in degrees mode and evaluate the value of the expression which contains an inverse trigonometric function, the value you are getting will be in degrees. Usually we don't consider degree as a real number because it's a unit of angle measure. Okay, when we keep our calculator in radians mode, the value we get for this expression will be a real value. When we evaluate a definite integral, the result has to be a real number. So when I want to evaluate the expression which contains inverse trigonometric functions, always we have to keep our calculator in radians mode. Okay, now let me keep my calculator in radians mode, and when I evaluate the value of this arc sine of 1 over 2, I'm getting a very long decimal, that is 0.5235, and it keeps going negative. When I evaluate the value of this arc sine of 1 over 9, again I'm getting a very long decimal, 0.113, it keeps going. Okay, so when I do subtraction, again I'm getting a very long decimal value, that is 0.41225, it keeps going. According to the instruction in the question, we have to round our final answer to 3 decimal places. So when I round this one to 3 decimal places, always I have to look at the digit at the 4th decimal place. That is to the right of the decimal point, consider the digit at the 4th place, which is 2. If it is 5 or greater than 5, we can add 1 to this digit, which is at the 3rd place to the right of the decimal point. But here the digit at the 4th place is not 5, it's less than 5. So simply we can ignore all the digits over here. We can consider just 3 digits over here. So when I round my answer to 3 decimal places, I'm getting 0.412. So this is the evaluation of the given definite integral.